This lesson is about the general layout of the periodic table, including various special areas that are named on the periodic table. We're also going to go over how the elements are laid out and what's special about them. You really should have in front of you right now a periodic table so that you can take notes on it and mark it off. You should also have some colored pencils or markers or some other kind of coloring, because we're going to be coloring the periodic table to go along with the different areas that we're going to mention. First thing that we want to talk about is this guy. This guy is Dmitry Mendeleev. He's a Russian chemist from the late 1900s who set up the periodic table. And people said, oh, what's so special, Mendeleev? It's just a table, right? You know, I can make a table of any sort of data. But Mendeleev saw something special. In fact, he saw that the way that he laid out the elements, they were in rows and columns of patterns that repeated. And we're going to talk a little bit more about how they repeated and what was special about them later this year. But you should know that that's Mendeleev's law, that the properties of the elements are periodic. They repeat in a pattern. You should also know that this is caused by the fact that the elements that repeat their number of valence electrons. Valence electrons being the electrons in the atom's outermost energy level. You should also know that the way that you count those valence electrons is just count 1 through 8 across the periodic table, and you skip the transition metals, which are those elements in the middle from scandium to zinc. And you can also skip the elements at the bottom in the rare earth metals. We're going to talk about all these different areas of the periodic table in just a second. All right, so this is the first thing. Mendeleev actually made his periodic table, so goes the legend, by putting cards out. And if we put these elements out, you see the elements all laid out across the top of the page. You probably notice that there's a pattern, and the pattern is in the color. So we see green, red, orange, and then a little bit we see blue, green, red, orange, and then a little bit we see blue, green, red, orange. Mendeleev said, why not put them in columns? And this pretty much forms the basis of the periodic table as we know it today. This is our periodic tables, and the elements that are in the same columns have similar properties. Here's a few examples. Over here, these are called the alkali metals. You don't have to write that down right now because we will write it down later. But all of these elements go into making salt, you know, like sodium chloride or potassium chloride. They all make different kinds of salts. They also, if you ever get them as a metal, they'll light on fire in water. So that's another thing that they have interesting in common. By the way, potassium, you know, we know bananas have potassium. That doesn't mean that when you put a banana in water, it will light on fire. It's already in water, so technically it already would have lit on fire if it did. But there was a story back from a few years ago. A bunch of MIT students threw a chunk of sodium in the Charles River in Boston. They got in trouble because an environmental cleanup worker came along later and was actually burned by the leftover sodium. So we still got to make sure to be very cautious around elements. Over here, these are ones some people are more familiar with: copper, silver, and gold. We know that these are the elements that most people use to make jewelry, especially silver and gold. Over here, these are the halogens. They're all very toxic, dangerous gases. Well, iodine's a solid. We actually saw it already this year. But fluorine's a gas, chlorine's a gas. Bromine, well, bromine forms a gas pretty easily. And actually, if you put those elements together with the alkali metals that are over on the left, you get salt. So sodium and chlorine make salt. All right, and finally, over at the very far right of the periodic table, those are all gases. Those are the noble gases. In fact, they're also similar because they don't do any sort of chemistry with any of the other elements on the periodic table. They don't bond with anything. They don't react with anything. They're noble in the way that nobility is noble, as in they don't want to associate with the commoners. All right. I told you that we'd learn how to count valence electrons. You'll see that the periodic table's here at the bottom, and we're going to count valence electrons based on this periodic table. Remember I said you just count over 1 through 8. So here's 1, 2, skip the whole middle. These are the transition metals. 3, 4, 5, 6, 7, 8. So everything in those columns has those numbers of valence electrons. So if we want to know about beryllium, find beryllium. It's over at the left. So beryllium over here has 2 valence electrons, so 2 VE. Carbon, which is way over here, has 4 valence electrons, 4 VE. Over here, krypton down here, is in the 8 column, so it has 8 valence electrons. And titanium is kind of in the middle, so we're not even going to really talk about it. Those middle elements do have valence electrons, but it gets very complicated, so I'm never going to ask you about those. Carbon, we already said it had 4. But what about the elements below it? Silicon and germanium. Well, those also have 4. Okay, there's one exception to this kind of general paradigm, and that's helium. Helium has an atomic number of 2, which means the entire atom only has 2 electrons. So helium's not capable of having 8 like everything else in its column. We put it with the other noble gases because it is a noble gas. It's got full energy levels. But helium is the one exception to this general trend. It has 2 valence electrons because it only has 2 electrons in total. All right, so you need to know how to count valence electrons for any of the elements in those areas that we pretty much can count. Skip the middle. All right, we're going to move on now to talking about, next, I can move on now. All right, the periodic table in general. So we're going to start coloring it. So get out your periodic table, get out your coloring stuff. There's a bunch of different ways you can color it. One way is you can kind of just fill it in, like fill in a whole box. That'll color it. Hopefully you use colored pencil or something so you can see through, because you still it'd be nice to see the elements underneath, but you can color in a whole box like that. Another way you can color, though, is by doing an outline. So if I do an outline of color of this whole area, that'll kind of tell me, oh, that area is all part of one big thing. So you could color like that. Another way you might be able to color is you could kind of shade or use vertical or horizontal or diagonal lines like this. That'll say that that element is one kind of element. And then this will say this element is a different kind of element. And you can go and kind of do those lines like that. All right, I'm not going to tell you exactly how to color your table, but I will tell you that certain elements, you're going to have to color them a few different times. So you're going to want to make sure that you plan this all out when you color your periodic table. Let me give you an example. Astatine over here, that's AT, is part of the halogens. So you're going to have to color the halogens somehow. And it's also part of the metalloids, which are these elements right here. So actually, I think I might want to go and shade those like this. So you can see, I can still see the blue outline, but I can also see the shading. And then I might also want to put some sort of other mark across it like this for the fact that it's, you know, it could be considered a non-metal or something like that. So anyway, just keep in mind that you are going to have to color the same element more than once. So let's go through some elements here. The first kind of elements that we're going to want to color are the representative elements in the transition metals. So the first 2 columns of the periodic table and the last 6 columns of the periodic table, those are all representative elements. They're all part of the elements that differ the most on the periodic table. The middle, the ones that we skipped when we counted the valence electrons, those are called the transition metals. All right, so let me give you a moment to color that somehow. By the way, the elements at the bottom, which I haven't pointed out here, all the way at the bottom, those are actually called the inner transition metals. So you might want to label those as inner transition metals. So they are transition metals. They're just a special kind of transition metal. So you can color them blue if you really want to. I'm not telling you what colors to use. All right. You should know that on the periodic table, periods are the rows. It's just another name for the row. So rows, remember, go left to right. So periods go left to right. So row 1 of the periodic table is period 1. That contains hydrogen, helium. Row 2 contains lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And row 3 and so on. All right, so those are all called periods. Groups, another name for family, are the columns. So they go up, down. And there's 18 columns on the periodic table. And they're numbered in various ways. So you'll see there's different numbering systems on different periodic tables. Sometimes they're numbered using Roman numerals and A's and B's. That could be the American or the European system. We're mostly going to, in our class, use the new IUPAC system. It just means number them 1 through 18 all the way across. So we'll see, I'll point out that next time we see a periodic table with it. All right. So next, we're going to move on to a different kind of shading, and that's we need to shade the groups. So these are the special groups on the periodic table. So the alkali metals, the alkaline earth metals, the halogens, and the noble gases. You definitely need to get down the labels for these. Must get down the labels. You also want to know the lanthanides and the actinides, which actually go left to right. So they are groups, but they're kind of weird. They go left to right instead of up and down. All right. You'll also see here that it's got some group numbering going on. This group numbering is done using the American system, which is usually done by Roman numerals, but here it's done by regular old Arabic numerals. All right, so again, make sure you copy down everything that I just circled and underlined, and make sure you shade the columns as appropriate. By the way, you might be asking yourself why it is that hydrogen is not shaded red like the elements below it. It's because hydrogen's not a metal. It's a nonmetal, which we'll see in a second. So here's some properties of these things and why they're special. Alkali metals burn in water. Alkaline earth metals you can use to make pottery and things like that. They combine with oxygen and they make substances that don't melt. Halogens are very reactive and toxic. They're oxidizers, which mean they burn things, and they also make salts. For instance, chlorine bleach can burn if you use it the wrong way. And noble gases, I already talked about, have completely unreactive elements with full energy levels. They don't make compounds. Rare earth metals are the ones at the bottom, rare earth elements. They're the lanthanides and actinides. They're not necessarily rare. That's kind of an interesting thing about the name. For instance, cerium, Ce, is one of the rare earths, but it's actually as abundant in the Earth's crust as copper is, and copper's not a rare earth. Copper is actually a pretty common element. All right, this is the last set of shading that you're going to have to do. The metals, the metalloids, and the nonmetals. You'll notice that essentially there's a zigzag line going on here. You should definitely write down the zigzag line on your periodic table, because this is essentially the dividing line between metals and nonmetals. The elements along that line are metalloids. Metalloids essentially are kind of in between metals and nonmetals. By the way, the zigzag line continues up here with hydrogen. And all of the elements to the left and below that zigzag line are metals. The elements above and to the right are nonmetals, and the elements right along the line are metalloids. So you should know that. Let's talk about what this actually means, though. So a metal is something that we know conducts electricity, it's shiny, it's malleable, it's moldable, has a high density, usually solid. Nonmetals are dull, brittle, low density. They can be gases, liquids, or solids. They're poor conductors of heat and electricity. Metalloids are kind of like both. They share the properties of both because they're on the line, and they're the semiconductors in computer chips. Those are metalloids. By the way, there are other properties. I'll talk about this slide in class.